Hello students, today we will discuss about the previous year Neet question. Here you see that in 2019 there are three problems on electrostatics. Number one, a hollow metal sphere of radius r. So suppose this is a hollow metal sphere of radius r. Suppose this is a center and the radius of this hollow sphere is r, and this hollow sphere is uniformly charged. So this is charged uniformly charged. Suppose the total charge is q. Now you have to find out the at electric field at r greater than r. That means outside this hollow metal sphere, and also the electric field at r less than r. That means inside this hollow metal sphere. Now if I take a point P outside this hollow sphere, suppose this is point P. Now the distance is suppose small r from this center of this hollow sphere. Now if I want to calculate electric field at point P, then we have to draw a Gaussian surface. Suppose this is a Gaussian surface. Now this is a small, we take a small Gaussian small surface. This is suppose the ds. The direction of this small area vector is along this direction, and the electric field due to this hollow metal sphere at point P is along this direction. That means the angle between electric field and area vector ds is 0. Now if I use the Gauss theorem to calculate electric field at point P, then the closed integral E dot ds, surface integral E dot ds equals to q internal by epsilon naught. Here you have to mind it that q internal, what is the q internal? Q internal is the charge inside this Gaussian surface. What is the q in? Q in is the total charge inside this Gaussian surface. So here this electric field, the angle between electric field and area vector is 0. That means cos 0 equal to 1, and electric field around this Gaussian surface is constant. That's why you can write E surface integral ds equals to q by epsilon naught. Here I have chosen that there is a charge q, so this will be q by epsilon naught. Now the area of this Gaussian surface is 4 pi r square, then it will be q by epsilon naught. So electric field will be q by 4 pi epsilon naught r square. So electric field is 1 by r square proportional to 1 by r square. So outside this hollow sphere, electric field is decrease when r is increase. So when r is increased, the electric field is decrease. Now you have to find out the electric field inside this hollow sphere. Suppose this is a point P inside this hollow sphere. So you have to draw a Gaussian surface. Okay, so here it will be E dot ds equals to q by, here will be q in by epsilon naught. Now q in into this Gaussian surface is 0, because in metal hollow sphere charge always resides on this outer surface of this hollow metal sphere. That's why the Qn equals to 0. That means electric field inside this hollow sphere is 0. This is the problem number 1. Now the problem number 2. Here you see that two parallel infinite line charge. Two parallel infinite line charge. Suppose this is a infinite line charge and there are another infinite line charge. This is another infinite line charge. This line charge is charge density is plus lambda, here is minus lambda. The distance between these two charge is 2r. 2r. This is plus, and this is minus charge. Now you have to find out the electric field at middle point of these two infinitely charged conductors. That means here is, suppose this point is P and the distance here is R and this also R. Now to solve this problem, first you have to know what is the electric field due to infinite line charge. Suppose this is a plus lambda. That means this line is charge density is lambda. Now you have to find out the electric field at a point P at a distance R. Suppose this angle is theta and this angle also theta. Then the electric field, you may calculate that electric field will be 1 by 4 pi epsilon naught into 2 lambda by r into sine theta. When this line will be infinite, so for infinite line, this theta will be 90 degree. How? If you increase this point, then you see that the theta will be increased. When this will be infinite, then the angle will be 90 degree. So for infinite line charge, the theta will be 90 degree. So it will be, electric field will be 1 by 4 pi epsilon naught 2 lambda sine 90 degree by r. So it will be lambda by 2 pi epsilon naught r. This is the electric field for an infinite line charge. So we have to use this formula. So here the electric field due to plus lambda charge at P will be lambda of plus charge will be lambda by 2 pi epsilon naught, here will be r because this is the distance r. Now direction, if I take, this is x-axis and this is y-axis. Now for this plus charge, the electric field will be along this direction, so it will be E of plus lambda. So it will be I cap. So if I take the vector, then it will be I cap. Now for this minus electric field due to minus lambda charge at P will be minus lambda will be lambda by 2 pi epsilon naught into r. Then for this infinite line charge, then the electric field will be along this direction. So both the electric field will be in same direction. That means I cap. So total total electric field will be the sum of these two electric field, because both electric field in same direction, so it will be lambda by pi epsilon naught r. This is the electric field. So this is the answer. Okay, so at point P, the total electric field will be lambda by pi epsilon naught r. Okay, now number 3. Here you see, that 2-point charge A and B having charge plus Q and minus Q. So this is the problem. So suppose this is a point A and this is a point B. Here is plus charge Q and here is minus charge Q. The distance between this charge is suppose R. Then the force will be Q square by 4 pi epsilon naught by R square. This is equation number 1. Now, if 25% of charge A is transferred to B, so the charge at A will be Q minus Q by 4, so it will be 3Q by 4. 25% means Q by 4. So distance is same, suppose distance is same, so at B it will be minus Q plus Q by 4, because the 20% of charge of A is transferred to B, so it will be minus 3Q by 4. This is the two charge. Now the force between these two charge, suppose F dash, so F dash will be equals to 1 by 4 pi epsilon naught. Here will be 3Q by 4 and this will be a 3Q by 4 divided by R square, because distance is same. So it will be Q square by 4 pi epsilon naught R square, and here will be 9 by 16, so it will be 9 by 16 F. So this is the answer. Okay, though this is the answer. This is the 3 problem on electrostatic in 2019. Now in 2018, here you see that an electron fall from rest through a vertical distance h. Okay, so an electron, suppose this is electron, and this electron is fall at from a vertical distance h. Suppose this is distance h in a uniform vertical upward directed electric field. So this electric field is along this direction. Okay, this is the condition number 1. Now condition number 2 is the direction of electric field is now reversed. So here the electric field is along this direction, keeping the magnitude same, and the proton allowed to fall. That means here is suppose proton is allowed to fall in same distance. Here is h is, suppose this is a h, distance is, height is h. Okay, now you have to find out the time taken by two charge, that means electron and proton. Here the force due to this electric field, so force experienced by electron due to this electric field will be along this direction, f of e. So f of e will be qe, that means qe, that means ee. Okay, that means the mass into acceleration will be by E by ME. Suppose this is, you have to calculate acceleration of electron. Now here is the electric force experienced by proton is along this direction, in same direction. So electric force experienced by proton is Q into E. The same, this is the charge is same E. Okay. So the acceleration of proton is E divided by m of proton. In both cases, there is a gravitational acceleration. So in both cases is same. So you, in suppose here in both cases is same, that's why you can neglect it for calculation. Now S, you have to use the one-dimensional formula. S equals to ut plus half a t square. So here is S equal to h and the initial velocity is 0. So 0 and half into a. A means here is E by m of E into, suppose this is T1 square. So it will be T1 square will be 2 MEH by EE. That means T1 will be root over 2 MEH by E into E. Here the calculation will be same, only the mass is different. So if calculation will be the same, that means here will be T2 will be 2 m of proton H divided by E and A, because charge of proton and electron is same. That's why this time is, there is a so T1 by T2 will be root over m of electron divided by m of proton. So m of electron is less than m of proton. That's why this is greater value. So if this is greater value, then T1 is less than T2. Okay, T1 is that means T is proportional, so it will be reverse direction. So it will be T2 greater than T1, because here is T is proportional to the mass. So T is proportional to root over of mass. So mass of electron is less than mass of proton. So the time taken by proton is greater than the time taken by electron. Okay, this is the condition. So this is the formula number, question number 1. Now there is another question in 2018. Here you see that the electrostatics force between metal plates of an isolated parallel plate capacitor C having charge Q and area A. So this is a plate. Suppose this is a plate. This is a plate. So the electrostatics force between the metal plates of isolated parallel plate of capacitance C, here is the capacitance is C, both are capacitance C, and charge is Q, here is area is A also a charge Q minus Q, it will be area is M. Now suppose the distance is D. Now this is plus. So the electric field at this point, suppose electric field at this point due to electric field due to plus q charge. Suppose this is point P. At point P is E. E equals to will be, we know that sigma by 2 epsilon naught. What is the sigma? Sigma is q by A. So it will be q by 2 epsilon naught A. Okay. So electric field at point P is q by 2 epsilon naught A. Now you may suppose that you have to put this plate on an electric field E. Then the force force experienced by minus q charge will be minus q into E, because suppose this plate is placed first, then this plate is create electric field at P is q by 2 epsilon naught A. Now after that you put this plate on electric field E, then the force experienced by this minus q charge is minus q into E. Then it will be minus q square by 2 epsilon naught A. Here you see that the negative charge implies that this is a attractive force. This is a attractive force. So the force will be of isolated charge force will be q square by 2 epsilon naught A. This is the answer. Okay, this is the question.